Hey, it's Rick again with Welding Training Solutions. As I mentioned in my introductory video, we're going to be focusing on the fundamentals here. The content I'm going to be sharing is mostly the why behind the how. There's plenty of videos out there showing you different techniques for welding and different welding positions, etc., with different processes. But what I want to focus on mostly in my content is the principles behind the process, the why behind the how. And so as we start on that, I think what makes most sense is to begin talking about the base metals that we're going to be welding. And so every material that you're going to weld has certain properties, certain characteristics. And those characteristics basically affect the welding process. What welding process you're going to use to weld those materials and how that material is going to react to that welding process. So there's many different properties that metals have. There's chemical properties, their resistance to corrosion, etc., its capacity to rust and so forth. Physical properties, density, which doesn't affect a lot about welding, but certainly the melting temperature does. And so different metals have different melting temperatures. And then, of course, physical or mechanical properties on how stress is involved in different materials and how they react to that. And so what I want to focus on mostly initially is take some of the most common materials and talk just a little bit about their basic properties and how that would affect welding. We'll probably get a little more into that part of it later, but for now, I just want to talk about the materials themselves. And so to start off with, I want to talk about carbon steel just briefly. Steel is basically an alloy, in reality, a mixture of carbon and iron. Carbon steel is generally 99.5+% iron, and the balance is carbon. Carbon is what gives it its strength, and different levels of carbon content affect the welding process as well, which we'll get into that more detail as well. But as we talk about carbon steel, there's really two different basic formats here, or forms, and that is we have hot rolled steel and we have cold rolled steel. There's a big difference in the two of them, not radically as far as their general properties, but in your ability to weld them. Hot rolled steel has a mill scale on it. Hot rolled steel, just like it sounds, was rolled hot in a steel mill. And so this, when it's rolled hot like that, it forms an oxide scale, which is called mill scale, because it was formed in the mill and through that hot rolling process. And that mill scale is an oxide. And some welding processes and even some electrodes with, for example, stick welding, that's a problem, and it would have to be removed. Some situations it wouldn't, and with certain electrodes and stick welding it would not. But that's one factor. Then you have cold rolled steel, which basically goes through another process, a couple of processes actually. After it's rolled hot, it's rolled again cold, which removes the mill scale, also work hardens the material or toughens it somewhat, and so then it has to be annealed and then rolled again. And so basically this material is scaleless, and so some processes would require that, or else the removal of all that mill scale, as I mentioned. But the weldability is basically the same. And so that carbon steel has a melting temperature of around 2,600 degrees. So just as a note, which we'll explain a little more later. And so that's the most common material, obviously, is just regular carbon steel. And then we have stainless steel. Stainless steel has many different alloys of stainless steel. We'll get into that later as well. The stainless steel has roughly the same melting temperature as carbon steel, but has some very specific characteristics as well. Carbon steel and stainless steel both have a low thermal conductivity, meaning basically they transfer heat very slowly. Stainless much more so than carbon steel. What that basically means is the heat stays in the weld seam longer, and so it gets hotter faster, and that affects different techniques and the process that we're using and so forth. Stainless is an alloy steel, so it's carbon and iron plus chromium and nickel and sometimes molybdenum and other elements to give it very specific properties. One of those properties is its corrosion resistance. And so you can put pure nitric acid on stainless steel and it's not going to do much to it. But you get this up to a higher temperature and it reacts very quickly to the atmosphere. Now, having said that, you need to understand that one of the things we have to do when we're welding is to protect that liquid pool of metal that we're creating in the welding process. We have to protect it from the atmosphere. 21% of the atmosphere we're breathing is oxygen, and that oxygen is an extremely reactive material, or extremely reactive gas that will react with liquid metals but also extremely hot material as well. Stainless is one of those that reacts very quickly and very radically to the atmosphere when it's at a red temperature or obviously melting temperature as well. So that's one of the things that we have to consider as we work with that. We'll get into, as I said, much more detail later on as we talk about welding stainless steel and, of course, the different processes and filler metals, etc. And then the third one that we'll just mention briefly is aluminum. Many different alloys of aluminum as well. Aluminum is very different from carbon steel and stainless steel. One, because it has a very high thermal conductivity, so it transfers heat very rapidly. So we have to overcome that in the welding process. And two, it forms an oxide on the surface that melts at like 1,000 degrees higher than the base metal does. And so we have to be able to electrically remove that oxide during the welding process and sometimes even prior to the welding process. And so melting temperature wise as well, it varies. The melting temperature of aluminum varies from anywhere from 1,200 degrees to over 1,500 degrees. And so it's going to melt much faster than will carbon steel when it gets hot. However, it takes more heat to get it to its melting temperature because it transfers heat so fast. And so that's the third thing that I mentioned is its high thermal conductivity. And so it has a lower melting temperature, has a higher thermal conductivity, so it transfers heat faster, and it forms that oxide on the surface during the welding process, which limits its use with different welding processes. And so those are just some basic fundamentals to get us started thinking about that. In a subsequent video, I'll talk more about very specifics related to that, which welding processes work better for these materials, matching the alloys, etc., all of that. So anyway, until next time, remember, you have to focus on the fundamentals. See you next time.